Hello friends, I welcome you all to this lecture on C programming. So in the last lecture we have written some programs. So in this also we'll be writing some more programs and using while loop only. So the question says that count the number of digits in a given number, print those digits, then sum those digits, then find the product of those digits and finally reverse the digits in a number. So how to do that? So let's say I'm having the digit 2542. Now there is a mathematical way of doing it. First, let us see that. So if I write this number in scientific form and then take the log of it base 10, sorry, there is a mistake. It should be into 10 to the power 3. Now if you do this, you will be getting log base 10 10 to the power 3 plus log base 10 2.542. So now this will be what 3 will come out. So this becomes 3 plus this is log of 2.54 is nothing but log of 2.54. So it is zero point 0.4. Okay, so close to that. So if I typecast this and convert this into integer, so what I'll be getting 3. So if I add that one, this number 1, then I'll be getting the number of digits. Simple. So what is the procedure? You take log base 10 of that number, then typecast it to integer, then add 1 to it. That is your answer. So let me show this to you. So right now I don't require any loop. I must have some number. So let me say that I'm taking 2, 3, 4, 5, 4, 3. So this is my number. So how many digits are there? 1, 2, 3, 4, 5, 6. So the answer should come out as 1, 2, 3, 4, 5, 6. So if I simply do what? Let me. So what I have to do? I have to take the log base 10 of this number. Okay. Then I have to add 1 to it. Okay, and typecast this to integer. So if I do this, what I'll be getting is the number of digits. Very simple. So if I run it, it is saying, oh, sorry, int n. N is the number which is assigned with 2, 3, 4, 5, 4, 3. So if I run it, so I'll be getting 6. Look. Or what you can do is, you can, let's say, I can make this 1, 2, 3. How many digits are there? 3. So answer should be 3. So in this way, you can use the knowledge of mathematics to get the number of digits in any number. Now let us do the conventional way. What is the conventional way of doing it? So let's say I'm interested in 2542. Okay. So 2542. So friends, if I take this 2 away, so this is my number and this is one of my digit in the number. So if I take this away and I count this as 1, then my number is this. So if I take this away again, then I increase it, then again this, then again I increase, then again reduce it, then again I increase. Now, what is the number now? It is 0. So if I start reducing the number, that means removing the last term, and then adding 1 to this count every time I remove that, and then I will be getting number 0. So I stop at this and then I print this. So this will be the number of digits in that number. Simple. So how to remove any digit, last digit, let's say, from this number? So if this is my number and I divide that number by 10, that is integer division I do. So int by int will give me what? Integer. So if the original number is 2542, I divide it by 10, so that will be 254.2. but this is integer division, so that point will not come. So in this way I can do what? I can remove that number, and once I do it, I increase the count. So this is a very simple thing. Okay, so let me show this in the program. So let's say I am having this number 123, or increase it a little bit like this, and I want to check how many digits are there. So what I'll be doing is I will be writing my count, okay, and assigning this with 0. This will be incremented only the when I remove one number from this number. That's it. Then what? Then use your while loop. While now, when your loop should stop, it should stop the moment number become 0. So it should be true always when the number is not equal to 0. So when the number is not equal to 0, then do what? Do this. You reduce n by that last digit. You remove that last digit. That is how we can do it. Once this is done, you increase the counter by 1. Okay. And once this is also done, what will happen? Your answer will come. So let me show this to you inside the program itself. That is printf %d, and let me show you how that number is getting reduced. Okay. So if I run this program, now see, initially the number was 123412. So 123412, that number is that last 2 is reduced, so number will be this. Then count will be increased by 1. Then it will print this and go again. Then this 4 will be removed, 1 will be removed, so this will be the 1. Then 4 will be removed, then 3 will be removed, then 2 will be removed, then 1 will be removed, and finally the number becomes 0. So moment it becomes 0, you have to come out. Likewise, what you can do is you can simultaneously print I also. In the first I will be writing I, and if I run it, oh, is there any mistake? Is there any mistake? Can anybody tell me what is the mistake? Yes, I is not there, count is there. So if I run it now, when I is 1, so that number has gone. When I is 2, this also has gone, and in this way, at the 6th iteration. So that is how the program works. So finally, what I have to do, I have to simply print the count. That means this. The number of digits is equal to count. So if I run it, the number of digits is 6. Look, 1, 2, 3, 4, 5, 6. That's it. If you change this number to, let's say, this, how many digits are there? 2. So number of digits is 2. It is very simple. Okay. Now, look, if I have to write the number of digits in this number, I am doing a mistake. You have to identify it. What will happen if I write like this? Let me run and show you, and then I'll correct the error. So number of digits in 0 is 2, it is saying. But what was my number? It was 1, 2. It was not 0. So then why it is doing this? Because every time I divide it by 10, the number is getting reduced. And finally, when it becomes 0, it will come out of that program. So I am assigning that reduction to n itself. So this is 0 now. So it is giving me correct answer. So what has to be done? I have to make one more variable, old number, and then assign the value of n to it before the loop start, so that the number can be preserved here. So now if I write in place of n this old n, and now check, so it is saying that the number of digits in 12 is 2. Likewise, if I change it to, let's say, this, then it will say the number of digits in 13212 is 5. So that is how you can preserve your number for future calculations or data printing. That's it. So this part is over, counting number of digits. Okay, then printing digits in a number. So now what we have done so far is we have just removed that last digit and we have not printed it. So let's say I'm interested in printing also. Then how I have to do this? So 2542, let's say, is the number. I have to print this. How can I do this? I can do this with the help of modulo operator. So if I evaluate the modulo, or I evaluate the remainder of that when divided by 10, so what I will be getting is 2. So that has to be printed. Then what I'll do? I will reduce the number. So this will be going, then this is left, then I will be doing this. So this particular two things have to be repeated again and again. So what I require, that I should have one remainder also. So let's say r. So r has to be defined. So let's say int r. So what is that remainder? It is nothing but n modulo operator 10. Okay. Then I have to then I have to print it. Print what? Print percentage d, then to new line, and that remainder. That's it. So if I do this repeatedly, then what will happen? First 2 will come out, then this 2 will be removed with the help of this expression, and then count is also, because in this program I don't require this count, so it will be incrementing, and now the number becomes 1 3 2 1. So then 1 will be removed using this, and so on. So if I run this program, so it will give me what? It will give me 2 1 2 3 1 in the reverse order, and the digits are already 5, so they are also getting printed. You can do what? You can write everything in one line using that comma. So if you run it, so it will be giving that this and this. So why it is coming in that line? Because we have not asked to do it. That's it. So the numbers are 1, so 2 1 2 3 1, and they all are in reversed order. Okay. So it is very simple to print the digits in any number. Then comes what? Then say sum of digits. Now we have to add them up, all the digits. So what is required? One sum is required. Initialize it with 0. Okay. Then once I get this remainder, what I have to do? I have to simply sum this up. So sum plus r. That's it. Now you got it. What is required? Now let's say printf percentage d, the sum of, sorry, the sum of digits in that number is equal to this. So in the first place this will be coming, and in this next place the sum will come. So let us bring the cursor to the next line also. So if you run it, so it will be saying that the sum of digits in this is 9. Check. 2 plus 1 3 plus 2 5 plus 3 8 plus 1 9. That's it. So it is very simple. Once you develop the program to find the digits, then that program that can be converted into printing the digits, and this same program can be converted into summing up all the digits, all the numbers in that particular sum. Then the next program, says product of digits. Now what I have to do? I have to simply multiply the digits. So previously I have used s as 0 started with, but now I cannot do this because the product, if I assign 0, then this will become 0 times that those numbers, so everything will come as 0. So what I have to do? I have to start with 1. So let us make one variable p here itself and assign 1 to it. Okay. Now what I have to do? I have to simply multiply that p by that r. That's it. So initially it will be 1 times the last one, then 1 times the second last one, and so on. So finally we will be getting the answer. So let us print this also. The product of digits in this is this. So here in place of s I have to write p. So if I run it, Now I'm getting this sum as 9, the product is 12. How? Because 2 times 1 is 2, times 2 is 4, times 3 is 12, times 1 is 12. So I'm getting this 12. So it is very simple. It is very simple to find out the number of digits, to print the digits, to find the sum, to find the product. Why it is not difficult for you? Because already we have evaluated the sum of first n numbers. It's very similar. And you also have developed that program of printing the number of, doing what? Finding the factorial. So that is how we are doing it. Similar way. Not the same, but similar. Now comes the next one. Reverse the digits of a number. Now this is important. You look, if my original number is, let's say, 2542, let us take another number 1234, let's say. So my output should be 4321. Okay. Now what I have to do, I have to first take this 4 out. Okay, I have taken it. I know how to do it. Remainder I have taken. Then I have to take this 3 out. Okay. Then I have to take this 2 out. Okay. Then finally 1. And when number becomes 0, it will come out of it. Now look. 4. Now 4, then 3. So once I take this 3, I have to multiply it by 10. Once I, and then add, once I take this 2 out, I have to multiply this by 10 and then add to 2. Once this is done, I have to multiply it by 10, then add 1 to it. So what I am doing basically, I am taking this R remainder. So let's say the reverse number is the 1. I am taking this reverse number. So this is basically the reverse number. This is the reverse number for the first iteration and second iteration, so on. Multiplying it by what? 10. And then adding that next number which is coming as the remainder. That's it. This is what I am doing here. Very simple. So if you start that initially, what will be the reverse number? It will be, let's say it is 0. Then 0 times 10 plus R. What is R? It is 4. So it will become 4. Next time, what is the reverse number? It is 4. So it is 4 times 10 plus what is the number we are getting as remainder? 3. So it becomes 43 and so on. So in this way we can reverse a number. Okay. So let us do it. So let us declare one variable as reverse number and assign 0 to it. Then what? Then I am doing it here itself. So reverse number will be reverse number times 10 plus R. That's it. Done. Now what I have to do? I have to print this. So I'll copy this. So the reverse of this number is equal to this. So this is old and this is Rn. So if I run this program, so it will say that the reverse of 13212 is 2. Look here, 2 is coming. So let me take different numbers so that it is much more visible to you. 1, 2, 3 and then 4. So if I run it, now look, 1, 2, 3, 4 is the number. So reverse number will be 3, 4, 3, 2, 1. That's it. So simple. Okay. So once you have reversed the number, you can also check whether the number entered by the user, right now I am giving here, but let's say whether a number entered by the user number is palindrome or not. What is palindrome? A number which when reversed give me the same result. Okay. So now what I have to do, I just have to print here, check here, if the old number is same as the reverse number, then simply print the number is palindrome. Okay, then close the statement. And else what you have to say, you copy this. You simply have to say that the number is not palindrome. So right now, if I look this number, it is 1 to 1. So if I reverse this number, I will be getting 1 to 1. So if I run this, what is the error? Okay, sorry, this is not Python, so I'm not permitted to do like this. Sorry, it happens sometimes. So if I run this program, again it is saying some error is there. What is the error? Look, OD is not defined. It is OLD. Oh, sorry, it is OLD. So this is the one. Oh, Y is not coming. YL is not coming. If I run this, else. Oh, again that same mistake. So if I run it now, the number is palindrome. Okay, let us take a number which is not palindrome, let's say 0. So if I reverse this, it will be 1021, not 1201. So this is not palindrome. So the number is not palindrome. So friend, in this particular lecture, what you have done so many things. You have played a lot with the numbers. You have counted the digits in a number, printed digits, sum those digits up, find the product of these digits, reverse the number, and also check that whether a number entered by the user is palindrome or not. So in this way you can write your program. It is very simple. So in this lecture, till this point only, what we'll be doing in the next lecture is we will be doing some more maths. Maths means we will be checking or we'll be finding out the roots of equation. Yes, we can do it using while loop, and we will also be finding the solution of system of linear equations with the help of your what we call it, Jacobi method or Gauss-Seidel method. So we'll be doing these also, so that you can understand that how one can use those logics and implement them in C program. So in this lecture, till this point only, thank you very much for watching it.